Hello and welcome to another thrilling installment of the geometry videos. This is a wonderful section about triangles and their side lengths. What we want to do is we want to analyze the relationships between the angles of an acute, right, and obtuse triangles, determine if three given segments will satisfy the triangle inequality. We want to determine if the length or parameters of the third side of the triangle given the other two sides. So let's talk quickly about the types of triangles before we do anything. So we have first what's called an acute triangle, okay? And I'm just going to draw a generic triangle here and make sure that all of my angles are acute angles. Okay, so I know that all angles are less than 90 degrees. Okay, that's what makes it an acute triangle, okay? The next one we have is a right triangle, and a right triangle is my favorite kind of triangle. Okay, right. Okay, and in a right triangle, one of the angles is 90 degrees. Okay, so in a right triangle, we have one angle that is 90 degrees. Okay, the other angles are going to be acute. Okay. So the other angles must be acute. All right. The next one we have is obtuse triangle. Okay. And if I were to draw a picture of an obtuse triangle, I first start off with drawing an obtuse angle. Okay. And then connecting those other sides. So an obtuse triangle is where one angle is greater than 90 degrees, okay? The other angles must be acute, okay? And while we're at it, let's stop there. I think that's good enough. All right, so what I want to do is we want to identify angle measures in obtuse triangles. What we said was that, over here I just said that, if one angle is greater than 90 degrees, we have one obtuse angle, the other angles must be acute. So what we know is that if we had this this obtuse angle here, all right, and let's say we connected P to R, okay, we know that angle Q is greater than 90 degrees, okay, so this is my obtuse angle, okay, so if that angle is greater than 90 degrees, then, we know that all of these angles have to add up to 180. If Q is greater than 90 degrees, then P and R have to be smaller than 90 degrees. So even the sum of the two, the other angles, the non-obtuse angles, okay, must be acute. Okay. All right, so let's take a look at this next part where it says analyzing possible side lengths of triangles. All right, so the triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so if I were to talk about length C, okay, length C must be smaller than the sum of A and B. Okay. Similarly with angle B, if I were to add C and A together, it would be larger than B, okay? If I was talking about side length A, I know that if I were to add B and C together, they'd be larger than A. So, let's just think of an example. I'm going to kind of think of a hypothetical example here. Let's say we have a triangle that is a 3, 4, 5 triangle, okay? And I'm always going to come back to this. This is one of my favorite triangles. Okay, and this is going to be a right triangle. Okay, but if I were to take any of these sides, okay, and what I like to do is take the two smallest sides. like 3 and 4. If I add 3 and 4 together, is that going to be larger than 5? And the answer to that question is yes. Okay, I should get 7 is greater than 5. All right. If I wanted to go over here and say, all right, well, let's talk about angle 4. All right. If I took angle 4, is that going to be less than the sum of 3 and 5? And the answer to that question is yes. So 4 is less than 8. That's a true statement. Okay, let's look at the last one. And the last one, if I take the side length of 3, is that going to be less than the sum of the other sides, which is 4 plus 5, or 5 plus 4? And we know that 3 is going to be less than 9, and that's also true. So if you have a triangle, if you take any of the two sides and add them together, it'll be larger than the third. Okay? So okay, before we move on and answer this question, let's make another box down over here. And let's call these more types of triangles. Okay? What we did up top, we based these off of angle measures. Okay? We can also classify triangles by their side lengths. So we have what's called a equilateral triangle. Equilateral triangle, okay? And that's when all sides are congruent. Okay? And the picture of that would just be something like this, where all sides are congruent. Okay? The next one we have is called an isosceles. And an isosceles is my second favorite. Oh God, how do you spell that? Isosceles. Isosceles triangle, okay? And that's when two sides are congruent, okay? And that would be something like this, where you had a triangle like this and only two sides are congruent, okay? The third option you have is called a scalene triangle. Okay, scalene, no sides are congruent. All right, so you just have something like that. Okay, none of the sides are congruent. All right. So then we have these kind of restrictions based on the side lengths. So what we have is we have this thing where, if we have an isosceles triangle, okay, we can have a right triangle, okay. All right, we can have a right triangle that's isosceles, okay. If we had an acute triangle, it can also be isosceles. All right. But then if you had, say, an obtuse triangle, you can also call that an isosceles triangle. So isosceles can kind of have a bunch of different types. You can have an acute, you can have a right, you can have an obtuse. But let's say you have an equilateral triangle.
Wouldn't that one be equilateral?
Well, equilateral, but
So all the sides are equal.
So all the sides are equal, right? But what about the angle measures?
It's acute.
It has to be acute. Okay, and so that's the thing, is that you've got, these types of triangles. What I have up here, these triangles are based off of angle measures. Okay. So you can classify triangles based off their angles. You can also classify angles by their side lengths. Okay. I'd like to conclude this video that I had a lot of fun making it.